And so the next slide shows the keystrokes of what I did. I plugged in my equation into y1, and then I did y1 at 2 minus y1 at negative 1 all over b minus a, or 2 minus a negative 1. And when you do all that, 1 should be your answer. Okay, and so the tricky thing is to make sure that we have the change in y in the numerator with all the parentheses that show up on this slide divided by the changes in x, again surrounded in parentheses. And so like there was a couple of you I noticed that had 2 minus 1, but we need 2 minus a negative 1 instead. Any questions before I move on from this slide?
Mister, how do you get the y1 in the calculator?
Who's asking me that? Leslie.
Leslie.
So did you watch either of those videos?
I don't think so.
Okay, if you go back, and I probably left it, and so like if you're on this, which kind of calculator do you have?
What do you mean?
Do you have the 83 or the 84?
84.
Okay, can you click on the link on this slide on your screen?
Yeah.
Okay, it'll take you to a video, and it shows at
Wait,
a
I can't. Never mind.
You can't do it?
No.
Okay, I'm going to try to put it in the chat. That will give you the step-by-step, and we're going to work on it a little bit. We'll practice it when we do one other thing in class. Okay, Leslie? So I'll show you one more time how to do that in class when we're doing some other stuff.
Okay. Thank you.
Yeah, you're welcome. Anybody else before we move on?
Mister, so the answer was 1?
The answer was 1. And it turned out that what it was it was 4 minus 1 in the numerator, and 2 minus a negative 1, which became 3 in the denominator, so it was just 3 over 3.
Oh, okay.
Better?
Yeah, thank you.
You're welcome. And so I want to tell you a quick story about something in third period, and you guys are crushing it already today with your questions, but I'm going to share with you just a quick story. We got to the end of the lesson, and there was like a check for understanding that I put up, but there wasn't time for me to go over it. And so I just polled the class. Hey, I asked a few students, and they said the answer is 24. And I said, how many other people got 24? And a bunch of hands went up. And so I said, okay, it looks like there's confirmation. I haven't done this one yet, but it looks like the answer is 24. Does anybody want to dispute that? And nobody spoke up. And so then I got a Teams message last night from a student saying, hey, Mr. Heffron, this is killing me. Like, everybody got 24 in class, but I got 8. And I just, it's driving me crazy. Can you help me? And so he put it in the Teams, and it turned out he was right. And he thought he was right then, but he didn't want to speak up. And it's super normal. Like that's going to happen, but he was right. It turns out the rest of the class was forgetting to divide by the change in x in the denominator. They were just working on the numerator, but not the denominator. And so, it drove him crazy because he'd been spending all this time on it. If he'd have just asked when he thought that maybe he was right, we could have all cleared it up. And I just want to encourage everyone, there are going to be times where you feel like you're the only one that either it doesn't get it, or like, oh, I thought this other thing was right, but everybody else has something else. And that's where I just want to challenge you to just have that like courage to be like, hey, wait a minute, Mr. Heffron. I'm not sure I get it, and I think I might be right. This is what I got. Can we at least look at it? And I will always try to make time for that, because that is the best learning, is the learning when you've been trying and you're getting something else, or you're a little confused. Always try to bring those things to me. And so I'm going to just put something in the chat. it's going to be just what you see on this slide, but I want you to put a thumb next to the thing that resonates with you the most. So I'm going to put these 3 things in the chat, and you're going to put a thumb next to one of them. That's the first one. Here comes the second one. And the last one. This is just another way for me to continue to help get to know you guys, because like I would probably be making some of these connections if we were all in the class together, but because we're separated by just, you know, space and time and internet, it's hard to see and we can't really tell. So just give me a thumbs up in one of these 3 things. I'm not surprised that there's quite a few thumbs up to the first one, because you guys are already really good about asking when you're not getting something. But I know that it's just super normal for there to be like, wait a minute, I'm kind of a shy person. I'm going to struggle with that, and I just want to know that. Everybody who's clicking number 2, I love your honesty. Thank you guys. And I just want to encourage you to do your best, because if you can take that risk, then I think that you'll learn even better, because you'll get your question answered in the moment. And maybe you were the one that had it right and everybody else was wrong. Okay. So what I'm going to do is we're going to go to the OneNote now. So I'm going to put the OneNote on my screen, and I want you guys to get your notes out, like somewhere that you can take notes and draw pictures. And what I want you to do is I want you to draw something like the axis that I've drawn here. So I want you to draw what I'm circling in yellow. If you have graph paper, that's great. Put it on graph paper. If you don't have that yet, try to get it. And for now, just kind of make your tick marks in the Y and in the X the best you can.
Mister, are you showing your screen?
I sure am. I thought I was. Is it not coming through?
Yeah, I can see it.
Oh, thank you for saying that. Let's see if we can't get... What was it not showing the whole time?
Yeah, I wasn't sure.
Oh, when I'm a doofus like that, please tell me. Thank you so much. Okay, is it showing now?
Yeah.
Great. Okay. And so what I want you to do is just draw an X and Y axis where you've got tick marks, every one going up and going to the right. You don't have to draw a building in, but I have a building there to just kind of show you that, hey, like in reality, we're going to talk a little bit about average rate of change in real life. And so I want you to draw what you see on my screen. Make sure to have the 6 shown and then the 5 shown along the x-axis. And then what I want you to do is put a dot on the 6 on the y-axis, essentially the y-intercept. And then I want you to put another red dot, 1 in the x and 3 above the first dot. And then from that last red dot, over 1, up 1. And you can hopefully sort of see the pattern now. Put those dots where I'm putting my red dots in your picture. And then draw the best you can a smooth curve between those. Now it turns out that the curve that we just drew is this h of t equals negative t squared plus 4t plus 6. And just for practice, Leslie, this is where I'm going to show it again, but just for practice, I want everybody to find the average rate of change for this yellow highlighted function, which is the one that describes what we drew on the interval from 0 to 2. And I'll practice it on my calculator a minute so that you can all be reminded how I'm doing it. First thing I'm going to do is plug my function into the calculator, a negative out front. Instead of t, I'm going to use x because that's the only thing you can use, plus 4t, or x in this case, plus 6. Can you tell me if I'm going too fast? Okay, then I'm going to do second quit to bring up the home screen. And now, Leslie, this is where I want especially you to just watch real carefully, but anybody else who had any trouble making the calculator sing. And by sing, I just mean like work really nice. I'm going to start with a parentheses, and then I'm going to do the rise. And the rise is going to be alpha trace. That brings up all of my different y equations. And since I plugged the one I wanted into y1 and it's highlighted, I'm going to hit enter. Now I want this at an x value of 2. And I'll close my parentheses. That's really my y1 or my y2. And now I'm going to subtract from that my y1. So I'll do the same thing, alpha, trace, y1. Now I want the x value of 0, because that's my first x in the interval. Then I'll close my parentheses, I'll hit minus, another parentheses, and I'm going to do 2 minus 0. Close that parentheses. Does anybody see the error? I just found an error in what I've put on my calculator, but I want to see if you guys are paying attention. It's with that minus right there. What should that minus be if I'm doing rise over run?
Division.
That's right. That should have been division, and so I need to fix that. Now when I hit enter, it should give me the right answer of 2. Okay, and that really means the slope between these 2 points, between x equals 0 and x equals 2, my slope, or my m, is equal to 2. Okay? And if I was going to draw that on my screen, I'm going to go ahead and do that in this light blue. All I'm really saying is, hey, between those 2 points right there, this blue line has an m equal to 2. Give me a thumbs up in the chat if this is making sense and you're good to move on. And give me a thumbs down in the chat if you're struggling and you need to talk a little bit more about this. That's perfect. It'll keep it simpler if you just give a thumbs up on top of Isaiah's. and a thumbs down. We'll start a new place for thumbs down. I'm going to start with a thumbs down just in case, to give somebody a place to put this, if I can figure out where the thumbs down is. Of course, this always happens. I can't find the thumbs down. There's only 2 people that have weighed in on top of Isaiah, so that's 3, and everybody else has said nothing. Does that mean you're struggling? This is where I really need you to kind of weigh in. Ariana, where are you at? Vin, where are you at? Justice, where are you at? Seeing a couple more thumbs up. Thank you, Perla. Thank you, Vin. But if you're a thumbs down, make sure to tell me. Thank you, Justice. Andrea, where are you at in all this? Thank you, Omar. Okay. That's really helpful. That helps me know that we're ready for the next piece. I can't find it on my student note, OneNote, but I understand it. Okay. And Andrea, it's not going to be on your student OneNote. This isn't something for you to practice that like I need to see. This is something for you to draw in your notes and have, but it doesn't have to be a drawing that you do in the OneNote. That's a great clarification. I'm just saying like what I'm showing, is it making sense? So the next thing that I want us all to calculate are what are the units of the answer we just found. And remember, the answer was 2. But I'm going to remind us we found it by saying f of 2, or not really f. We said we were using a height function. So we would have h of 2 minus h of 0 all over Vin. What would go in the denominator? This is like we were finding the average rate of change of rise over run. What would go in that denominator? Let's look back at the calculator. What did we have up here? It was hard to see. But if I go back up here, what was in our denominator?
0.
0 was one of them. And what else was there?
And 2?
Yeah, it was 2 minus 0. So this was really our x2 minus our x1. And this was our y2 minus our y1. That's all we're doing when we're finding these average rate of changes, is we're just finding slope. And so Moses, here's my question. I want the units for the answer. So if you just think about the numerator, this h2 and this h0, the things that are represented on my picture with the green highlighted dots, what are the units of those two heights?
Is it meters?
It is. It's meters. That's exactly right. So that's in the numerator. Isaiah, what are the units of the denominator? Again, that 2 and that 0. What do those represent?
Run.
They represent run. What are they in units? Like, what do they represent in real life? You might need to look at the graph again.
Oh, seconds.
Yeah, it's seconds, because over time, that ball goes up and then comes back down when we throw it off of the roof of that building. So the units in the denominator are seconds. Okay? And so we're starting to really get into calculus now. What does meters per second really represent? What does that represent? If I tell you meters per second, what's another thing that has similar units as meters per second? Like when you drive in the car, how do you measure? What does the speedometer measure? 50 miles per hour, right? Do you notice any similarities between meters per second and miles per hour? And is there anything else kind of like those two that you've ever heard of, maybe in physics back in 9th grade?
Isn't it speed or velocity?
Yeah, it's speed or velocity. The other one I was thinking about is feet per second. That's another. These are all units of velocity. And velocity is really something called a rate. In this case, it's the rate distance, or height. We'll say height in our problem. It's the rate height is changing over time. Okay? And so the answer to that third question, the one in part C, what is the meaning of the AROC of height on the interval from 0 to 2? Well, it's just the velocity of the ball. And so calculus, we're going to write this up here, calculus is the study of rates of change and one other thing called the integral. And these rates of change that I'm going to highlight, a rate of change, there's another word for that. It's called the derivative. So there's two main pieces to calculus, the integral and the derivative. And the derivative we just talked about. Okay? And so I want everybody to blow up on this picture. Really look carefully at your picture. Does everybody have a pretty good picture of the path of that ball over time? It's actually not rhetorical. Myra, do you have a pretty good picture? Have you drawn one? Same thing, Melissa. Same thing, Andrea. Same thing, Jaime. I want to make sure that you've drawn a good picture. Melissa, you don't have to draw on your screen. I'm not intending you to. I want you to be drawing in your notes right now. This should all go in a piece of paper. Your touch screen, you'll never be able to draw on the content library. For you to be able to draw, this would need to be in the collaboration space or on your own screen. And so this is just a place, like hopefully you've made a picture on your notebook. Does that make sense, Melissa? And so on your picture, I want you to draw a new slope. I want you to draw the average rate of change on the interval from 1 to 2. We drew our first interval was 0 to 2. We're not going to, in fact, I'm going to erase mine. We're going to draw a new one. You don't need to erase yours, but I'm going to erase my old one. I want to draw a new interval, this time from 1 to 2. So what is that going to look like on our picture? Take a second to draw the slope. We're going to draw the slope that represents the average rate of change from 1 to 2. And I want you guys to do that while I take a quick minute to take attendance. Once you've drawn your picture, I want you to calculate that new AROC. What is that new average rate of change? What is that new average rate of change? If anybody knows what happened to Isaac, you might ping him and ask him to join us. Okay, so I'm going to draw in what I was hoping that you would draw in. I'm going to draw this one again in light blue. Now it's this line right here. And then does anybody have a new slope there? What would that slope be, do you think, Morella?
I'm not sure yet.
Did you try doing it on your calculator?
Yeah, I'm kind of like confused a little bit.
So let's just pull up that. Let's pull up my calculator one more time, because one of the things I wanted everybody to see is once we have, Morella, were you able to put in the Y1 and the...
Yeah, I did all that.
So the nice thing about these calculators is you can arrow up, and now you can just edit it instead of retyping it all in. Now we want things from 2 to 1. So I can leave that first 2 and change that 0 to a 1. And again in the denominator, change that 0 to a 1 and just hit enter. Looks like I've added some things. Hold on. Somehow it copied something. There. And so now notice the average rate of change is only 1. And the first one, if we recall back, was 2. So that slope is getting less and less, isn't it? And here's where we dive into calculus. Morella, were you able to reproduce that or not?
Yeah.
Okay. Everything we've talked about so far is an average rate of change. Who can tell me how you find an average? Like if you're going to find the average of test scores, what do you normally need to find an average? How many tests do you need, at least? Madi, how many test scores are you going to need to actually calculate an average? Can you do an average with just one? Did you hear me, Madi?
No, I'm sorry. Can you repeat
Yeah,
that?
I'll repeat it. If you're going to find the average of test scores, how many at least? What's the minimum number you need to find an average?
One.
Sort of, but like there'd be nothing to average out, right? It would just be that one score.
Oh, my fault. Like more than two, at least.
Or at least two, right? Like if you had two, then you would add them together and divide by two, right?
Yeah.
And so this idea of average, this average really means 2 points. And this one right here, this one would have units, again, of meters per second, and it would be the velocity between, and this is where it's important, so make sure you're writing this down, the velocity between time equals 1 and time equals 2. So it's not velocity right now at an instant, but it's over time. And so here's the new piece of calculus. What we're searching for is something called a rate of change at one single instant. Boom! Right now. We want a velocity. I'll put my face on the screen so I'm not just making noise. Boom! Right at that one instant in time. Not from 1 to 2, not from 0 to 2, but right at 1. If we were going to do that, if we were going to find the velocity at t equals 1, what would the interval be, do you think, Leslie? What would our interval be if we were looking at it right at 1? Wouldn't we be looking from t equals 1 to t equals 1? If we wanted at one particular instant. Does that make sense to you guys? It's no longer an average rate of change, but we're going to call this new thing an instantaneous rate of change. And so I want to draw on our screen what it looks like. It's no longer between 2 points. It's right at 1 point. It touches the graph at exactly 1 point, and we call it a tangent line. So this instantaneous rate of change that I just defined is the same as the slope tangent to the curve at only 1 point. That's what a derivative is. And we're going to spend the next 4 months probably talking about derivatives. And that's what they mean. Miguel, are you with me? I want to ask you a specific question. And I want everybody to listen and think about the response.
Yeah, what's up, mister?
So if I wanted to do at one single instant from t equals 1 to t equals 1, could I do rise over run?
Yes, question mark.
Okay. Let's look about what it would be. I'm going to make some space over here. If we were going to use our equation, wouldn't it be height at 1 minus height at 1 all over 1 minus 1? If we were just looking at it at one exact point, wouldn't that be what we have? I want you guys to try that on your calculator. Do just what we did. I'm going to do it too. Let's see what happens. So I'm going to just edit what I had before. But everything gets a 1 this time. Height or y at 1. We keep that 1. There's a 1. And that's a 1. And I hit enter. What did I get? Well, what I got is an error. Because what this turns out to really is, these are the exact same thing, aren't they? So we have some number, whatever it is, the same number minus itself, all over 1 minus 1, and we end up with 0 over 0. And we can't do that. It's impossible. So can anyone think of how we could estimate the slope at t equals 1? Because we've just decided we can't actually find it because we get an error. So I want you to think about this for a minute. How could we estimate what that slope is at 1? Right at 1. It's not the black tangent line because we can't do the tangent line, but it's maybe close. Mandela, any idea? Think about a different average or a different interval. Perla, any idea? Jaime, any idea? Moses, any thoughts? Come on, guys, just tell me something. Just tell me something so I know you're trying. What about this average rate of change? Is that better if I went from 1 to 1.5? Is that going to be closer to exactly at 1? Closest decimal. Tell me more. Tell me more about that. That's okay, Moses. Isaiah, tell me what you're thinking about closest decimal. Again, we're searching for the exact slope at 1.
It's what I mean with the closest decimal is that it's
hard to explain, but do your best.
it's like it's near to 5 to 4, where how many points
Yeah.
it's from.
So like this green one, I went from 1 to 1.5. Could I go from 1 to 1.1? Would that be better?
Yeah.
What would be even better than that? What if I went from 1 to 1.01? Is that closer than 1.1?
Yeah.
Yeah, because you're
Yes.
only 1/100th away, right? Melissa,
Yeah.
what's even closer than 1.01? Leslie, what's even closer than 1.01? What if we went 1.001? What I'm really saying when I look at this graph, deleted too much. If I put a dot as close as I can get to 1 and draw that average rate of change, it looks just like the tangent line. And so where we're going to pick up tomorrow is we're going to do some average rates of change. We're going to start far away. Then we're going to get close. Then we're going to get even closer. And finally, we'll get so close that this average rate of change is almost equal to the instantaneous rate of change. That's where we're going to pick up tomorrow. But what you see here should be enough to try the new homework, which will go in as 8.27 for today's date homework, and it'll be due tomorrow. And I'll be looking at the ones you guys turned in for today. That's one of the things I'll do later today. Any questions before we sign off? Oh, and one more thing. Go ahead.
Homework?
What's that? Maddie, you
said
didn't.
we have homework?
We did have homework, but you were like not really in yet. So you'll have homework tonight. That'll be the first one you're responsible for.
All right.
Okay?
Mister,
Yes.
can you show the whole screen? Because I missed one part of the note.
You can. How about that?
Yeah.
And also, I am doing a video. And one last thing for you guys. If you're having trouble with the calculator or whatever, I will have office hours today, right after school, right after your last class. And I will be sending out a link in one of the postings. Like it'll come through as like it's coming from this meeting. And that's the link you'll go to, because I'm also going to offer it to period 3. So if like, anything with the calculator or anything about today, whatever, you want to get a little bit more help, you can come with that. And I will also post this video of our lesson when it's done. Okay. Go ahead, Moses.
Exactly, my bad.
What's that?
What exactly is the homework?
So the homework will show up in your student page. It's going to look just like what you see on the screen. It'll look just like what we just did. Okay.
Yeah.
But it hasn't showed up in your student page yet because I haven't posted it. I was going to wait until class to make sure we got through everything we needed to.
All right.
Okay. Great question. Any other questions before we all sign off and go to our next class? Did you have a question, Morella?
Yeah, can you go back to the other screen though?
Yes, I can. Period. Let's see, is it here? Yeah. Tell me where you want me to zoom. Everybody else, you're welcome to sign off as you guys want to.
So like the graph, can you zoom into the graph?
Yes, I can.
So I started kind of getting lost when you were like talking about the tangent line.
Yeah, so I'm going to just draw something really quick right here. This is a secant line or an average slope between 2 points. Agreed?
Okay.
If we want a tangent line, it would touch this curve at only 1 point. So it follows exactly, it's parallel to the curve at only 1 point.
Okay.
And mathematically, it's hard to do that because when you do rise over run, you're only looking at 1 point, so your delta y over delta x is always 0 over 0.
Okay.
And so instead, what we do is we say, hey, wait a minute. Let's get really close. Let's make our average rate of change between that black and red dot so close that what we really have is the function at 1 minus the function at 1.001.
So you get the decimal because like you can't do 1.
Yes.
So you have to do like the closest thing next to 1.
Exactly, because if you do 1 exactly, you'll get 0 over 0.
Okay.
Okay, but if we go really close, then we'll actually be able to get an answer, and that's where we'll start tomorrow. And that's the last question on your homework, so give it a try.
All right, thank you.
Okay, great question, Marilla. She did just...
And Mr. You're saying my name wrong.
Oh,
Sorry.
how do I say it?
I should have told you.
No, that's okay. How do I say it?
Mireya. Like,
Okay.
Mireya.
Yes, Mireya?
Yeah.
Okay, I mean, I'm going to get better at that, but I'm going to write it down right now, and we all have to go because we're all going to be late. It's my fault. Tell your teachers I suck. They already know that, but great job today, everybody. We won't, jump in without doing a little bit of more review of what we just went over with Mireya. How was that?
Yeah, that's good.
Okay. All right. Bye, guys. We all got to go. Great questions, though.